Here I have considered another example so that we can get the proper idea of the application of KCL. This is the problem given here. Find out the power delivered by the current source. Okay, and this one is the circuit event. This problem can be solved by using KVL also because three loops are there. This one, and this one. Three loops are there. So by using KVL, we can also solve out this problem, but it will take huge time. This is the problem related with GATE 2014. Okay. So now, how could we solve this problem? So let's remember that this type of problems can be solved by using KVL also, but we will apply KCL here because KVL will take huge time. On the contrary, if you apply the KCL, then it will take very short time period. Okay, thus you can save your time. So how could we apply the KCL for this particular circuit? So find out the power delivered by the current source. So this is the current source, 2 ampere current source. Now you have to find out the power that is delivered by this current source. We know that power equals to VI. So the current which is flowing through this voltage source is 2 ampere. So we know the current I is known to us here. 2 ampere, it is given. Okay. Now you have to find out the voltage associated with this current source. How could we find out the voltage for this current source? First of all, for this circuit we will apply Kirchhoff's current law, and for this you should consider a particular node. So here preferably we have considered this node as ground node where potential is 0, and what is the voltage there or potential there we don't know. Let's consider this node as X node, and the voltage at X node equals to, say it is Vx. Here we have considered the voltage for this X node is Vx. Now what is the voltage for this particular node? Let's consider the voltage for this node is say V1, and the voltage or potential for this node is V2. Okay, and for this X node the voltage is say Vx. Clear? Now from this diagram it is clear, for this branch 1 volt is applied. Okay, so this node is having V1 voltage and this node is having 0 voltage, and in between these two nodes 1 volt is applied. Thus easily we can say that V1 is nothing but 1 voltage. So here V1 equals to 1 voltage. Again, if we consider this branch, okay, there is a node V1, there is another node V2, and in between V1 node and V2 node 1 volt is applied. So we know that this applied voltage is nothing but the potential difference between this node and this node. whenever we are considering this branch, at that time the potential difference, that is V1 minus V2, is nothing but the supply voltage V1. Is that clear? So we can write there V1 minus V2 equals to 1 volt, and V1 is 1 volt. We know that V1 is 1 volt. So from there we can get V2 equals to 1 minus 1, that is 0 volt. So here V2 is 0 volt. Now considering this particular node and apply the KCL for this node. Let's consider all the currents are entering to this particular node. Let's consider all the currents are entering, because we don't know whether current is flowing from X node to this node or from this node to X node. So better we will consider that currents are entering. Similarly, from this particular node, let's consider current is also entering to the X node. Same thing. And here the direction is given, that is 2 ampere current is entering to the X node. So it is given. So no problem with this direction. So already it has been given here. But in these two, in case of these two branches, we have considered currents are entering. Okay. If we apply the KCL for this particular node, X node, we can write for the entering current, that is positive sign, it will have positive sign. So far I have discussed this thing, that it will have positive sign due to the entering current. And as current is flowing from this node to that node, that's why obviously V1 should be greater than that of the Vx. Okay. So what is the potential difference for this branch? V1 minus Vx. That is the potential difference for this branch. And this potential difference divided by the impedance or resistance, that is 1 ohm, that will give you the current which is flowing through this branch. Okay. Then again another current, that is again entering current. That's why it is also considered as plus. Similarly, so that should be greater than that of Vx, as current is flowing from this node to this X node. That's why we should consider V2 as greater than that of Vx. So potential difference is V2 minus Vx divided Vx, that is the potential difference, and then this potential difference will be divided by the resistance for this branch, which will give you the current. Okay, so these two currents we have come to know here. And now another current is 2 ampere which is entering. So again this is plus 2 ampere, that is the sum of all the currents in this particular node equals to 0. That is our case here. As we know that V1 is 1 and V2 is 0, then we can write 1 minus Vx by 1 plus 0 minus Vx by 1 plus 2 equals to 0. So by simplifying this equation, we can get Vx equals to 3 by 2. 3 by 2 volt. So this is the value for Vx. In this manner we can find out the potential or voltage Vx at this particular node, that is at this X node. Okay. Now you got Vx and current is available there, that is 2 ampere. So if we consider this branch, two nodes are associated with this branch. One is X node and another one is ground node. Okay. So what will be the potential difference? That means Vx minus 0 is the potential difference for this particular branch. So here it is 0 and here it is Vx, that is derived as 3 by 2. Okay, so what will be the potential difference? That is Vx minus 0. Vx minus 0, that is ultimately 3 by 2. So we get the voltage V equals to Vx here for this particular branch. Vx equals to 3 by 2 volt, 3 by 2 volts, and current has been given, that is 2 ampere. So what is the power? P equals to, we know, Vi. Okay, so power is 3 by 2 multiplied with current 2, that is 3 watts. So power delivered by this current source is 3 watts.